These are our notes from yesterday carried into yesterday, and what you guys know or what you've learned so you're able to practice it. And we're going to add an extra little piece. It says the goal is finding the inverse of almost any function. Well, we're going to talk about linear, quadratic, and now the new one, which is exponential. So let's talk every time you guys did a linear function and you found the inverse linear function, it was always a new linear function, meaning if I had a line, the inverse of that line, how did it change? Well, the slope was now the reciprocal. The slope was the reciprocal. And our y-intercept changed too. And it actually changed by being divided by that slope. So when we have a linear function, well, what about quadratic? And you did 2 of those or 4 of those for homework last night. The inverse of a quadratic was what? Even if you don't want to say it out loud, maybe like look back at your homework and just kind of say, well, what symbol was this? Or what did undo the square? Yeah, Quincy, it was a square root. It was a square root. So in our square root function, everything got really jumbled up. It wasn't as easy to kind of pin down as this right here, where I could just say the slope was inverted. Everything got kind of backwards. So it was just some combination of our square root function. So this is the new one you guys discovered yesterday. You watched a video on it. We have not done anything with it, so do not be afraid of it. Exponential function, which exponential looks like this. What is the inverse of an exponential function? Yeah. It's a logarithm. So the general formula for that is y equals log base b of x. There is going to be some kind of a little base right there. That base is always going to match this base over here. So we know quadratic and square root. So let's explore x 2 to the x. Because if you're like me, exponential function is not necessarily something I think about all the time. We don't use it as often. So let's make sure we know what we're doing with this. So I'm going to start at 2 to the 0 because 2 to the 0 is one of those things that is always branded in my brain. Anything to the 0 power is just 1. And then I think we can easily fill in the rest of this table. So take a moment and create a table for this linear function. Fill in as many of these values as you can. Does anyone think they can tell me what 2 to the negative 1 or 2 to those negative powers are just in the denominator. I prefer the fraction because you actually see the 2 there. So like 2 to the negative 3 would be 1/8. You see 248, 248 when you're actually looking at the fraction. But the decimal is appropriate too. So let's graph these. Remember, this is like x and y. So this would be the point 0, 1. And then this would be the 0.12. And this would be the 0.24. Followed by the 0.38. Working backwards is where we have our negative powers. So if I think of 2 to the negative 1, that's the same as saying 1 over 2 to the first. That negative power creates the 2 in the denominator. So that's how I got 1/2. So let's go ahead and plot that. At negative 1, we're going to plot 1/2. And then 2 to the negative 2, well, let's move that to the denominator. It's same as saying 2 squared, but in the denominator. Remember that negative power moves us to the denominator. So now that's just 1/4. And this should look like a function you're familiar with. So when we connect these dots, this goes off to positive infinity. And this is going to just skate along the x-axis. It will never actually touch 0. It'll just get, that fraction is going to get smaller and smaller and smaller and smaller, but it will never touch. So let's talk domain. Starting on this end, all the way to this end. Are there any restrictions? Are there any holes? Are there any stopping points? Does it start somewhere? Does it cut off? What do you guys notice about the domain? So just nod with me. Does the graph have like a distinct starting point in the x direction? Yes or no? Like a single point that it starts on? It doesn't. Does it have any like major gap or hole right in the middle? Does it have an asymptote, meaning this line? No, it doesn't have any of those things. So our domain is just negative infinity to positive infinity. There are no restrictions on our domain. But now let's talk range. Because range is going to go in this direction, from negative infinity up to positive infinity. So I'm going to ask you the same questions. Is there one point, one significant single point where our graph starts in the y direction? Kind of, but not really, right? Kind of, but not really. Is there a big, huge hole or a part of our graph that just is not there? So where does our graph actually start? Because I see like these kind of like uncertain nods, and I'm agreeing with you. There is this like uncertainty. Where does our graph actually start? There's nothing down here, guys. There's nothing. There's no negative numbers whatsoever. So I think our graph starts at 0. But does it go upward forever and ever and ever? Yeah, it totally does. Thank you for those of you who are still nodding with me. That helps know that, first of all, you can hear me, and second of all, that what I'm saying makes sense. The only question now is, do we see a single solid point on 0? Do we see like, bam, a dot? This point is equal to y equals 0. And we don't. Thanks for those shaking of the heads. We don't. So it's just a parenthesis. We do have one intercept. This one lonely intercept right here. We have a y-intercept at 1. And believe it or not, we do have an asymptote. We have an asymptote. There is this imaginary line right here that our graph is never going to cross. And I'm drawing it slightly below the x-axis, but it is just the x-axis. It is never going to cross the x-axis, which is y equals 0. Okay, so there's our exponential function. Let's talk logs now. Logs are everything just the inverse. Everything of this, but just the inverse. So do me a favor. This is going to be log base 2 of x. Try to create a table for me. I'm going to try to create a table knowing that it's just the inverse. And try to create a graph, again, knowing that it's just the inverse. Look down at your paper, test yourself up if you want to see if you were right or not. Same with the graph. Look down, try it on your own, but then look up to see if you were on the right track. So I'm going to talk through how I created this. Keep drawing it. When I created my table, I and switched them. That's all I did. Swapped to become 1/4. -1, 1/2, swapped to -1. Points that I plotted. I plotted those inverted points. And what I do see, and I'm glad that I see this, is that there is this perfect reflection over the diagonal line, y equals x. They're mirrored. I could just kind of fold the graph in half and they would just perfectly lay on top of each other. So let's talk domain, range, intercepts, asymptotes. Well, our graph has just swapped x and y. So guess what? Just swap also. The domain is 0 to infinity. Do you guys see that? The graph starts here along this line and goes off to infinity. Our x values are 0 to infinity this time. Our range is now -infinity to +infinity. There's no restriction on our range. This arrow tells us it goes all the way down to -infinity. This arrow tells us it'll eventually go up to +infinity, albeit pretty slowly. So not only do our x and y coordinates switch, but our x and y domain and range just swap. Same thing. If we had a y-intercept at 1, now we have an x-intercept at 1. Our y-intercept becomes an x-intercept at 1. And if our asymptote before was the x-axis, hopefully you guys can predict this. If the asymptote was the x-axis and we're just switching x and y, well, now our asymptote is the y-axis, or the line x equals 0. So without understanding what the log function is itself, we can look at the exponential function and just invert everything. Invert the graph, invert the table, switch the domain and range, which is really just inverting x and y values, and what a logarithm is. Okay, that's all I have for you guys about exponential and logarithms. Hopefully this kind of tied into what you watched in the video last night about exponential being exchanged. All you have to know at this point is that the only way we can take the inverse of an exponential function is with a log.